In this video, explore advanced techniques for extracting features in NLP, learn to transform raw text into valuable data, and equip yourself to implement these techniques using Python. Welcome to our deep dive into the world of feature extraction in NLP. Did you know that without proper feature extraction, even the most sophisticated NLP models can falter? In this video, we'll explore why feature extraction is a cornerstone in natural language processing, how it transforms raw text into data, and why selecting the right features is crucial for your project's success. By the end, you'll not only understand the theory but also know how to implement these techniques using Python. Let's get started and open the doors to NLP excellence.
Feature extraction in NLP is the process of converting raw text into a format that can be understood by machine learning algorithms. It involves transforming text data into numerical data, which is essential for any statistical model to work effectively. This step is crucial because, without it, the raw text remains incomprehensible to models, leading to poor performance. Different techniques can be applied based on the project's needs, such as simplification for speed or complexity for depth. Mastering feature extraction lays a solid foundation for building successful NLP projects, allowing you to unlock the full potential of your data. Bag of words, BO, and TF-IDF are two foundational techniques in feature extraction. The bag of words model is straightforward, it counts how often each word appears in a document. This simplicity makes it easy to implement but at the cost of ignoring context and word order. TF-IDF, or term frequency inverse document frequency, builds on BO by considering the importance of a word in relation to the entire dataset. It helps highlight unique words that are more informative. Choosing between these depends on your project needs, BO for simplicity and speed, or TF-IDF for a more nuanced understanding of word importance. Word embeddings are a powerful advancement in feature extraction, as they capture the semantic meaning of words. Unlike traditional methods that use sparse vectors, embeddings represent words in a continuous vector space, preserving the context and relationships. This allows models to understand nuances like synonyms or word analogies. Word embeddings are especially crucial for deep learning models, providing a dense and informative feature set that improves model performance. By using embeddings, you can create richer features that go beyond simple counts, opening the door to more sophisticated language understanding. Word2Vec is a pioneering word embedding technique developed by Google. It creates word vectors through two models, continuous bag of words, CBOW, and skipgram. CBO predicts a word given its context, making it efficient for large datasets, while skipgram predicts surrounding words given a target word, capturing more intricate relationships. Both models transform text into dense vectors that reflect semantic meanings. Implementing Word2Vec is straightforward with Python libraries like Gensum, allowing you to harness this technique's power in your NLP projects, enhancing the depth and richness of your feature extraction process.
BERT, or bidirectional encoder representations from transformers, represents a breakthrough in NLP feature extraction. Unlike traditional embeddings, BERT provides contextualized embeddings, considering the entire sentence for each word, thereby capturing nuanced meanings. Pre-trained models like BERT can be fine-tuned for specific tasks, significantly improving accuracy and language understanding. With libraries like Hugging Face in Python, implementing BERT in your projects has never been easier. By leveraging transformers, you can achieve state-of-the-art results in NLP, making your feature extraction both cutting-edge and highly effective.
In feature extraction, managing high-dimensional data can be challenging. Dimensionality reduction techniques like principal component analysis, PCA, and T-distributed stochastic neighbor embedding, TSNE, help by reducing the number of features, removing noise, and retaining important information. PCA simplifies data by transforming it into a set of uncorrelated variables, while TSNE excels at visualizing high-dimensional data in lower dimensions. These techniques balance model performance and complexity, making them invaluable when dealing with large datasets. Mastering dimensionality reduction allows for efficient and effective feature extraction, enhancing your NLP project outcomes.
Python is the go-to language for NLP thanks to its rich ecosystem of libraries like NLTK, Gensum, and Hugging Face. These libraries provide tools to implement various feature extraction techniques efficiently. In this section, we'll explore hands-on coding examples, demonstrating how to transform the theoretical concepts we've discussed into practical applications. Whether you're implementing Word2Vec, using BERT, or applying TF-IDF, Python offers the versatility and power you need to excel in feature extraction. By the end of this block, you'll be equipped to apply these techniques in your projects, turning raw text into actionable data. Choosing the right feature extraction method is pivotal to your project's success. Start by aligning your feature selection with your project goals and business objectives. Evaluate the methods based on model performance, considering trade-offs between accuracy, speed, and complexity. It's essential to perform iterative testing and refinement, ensuring that the features you select contribute positively to your model's outcomes. By understanding and evaluating these methods thoroughly, you can make informed decisions that enhance your NLP project's effectiveness and align with your overarching goals. Congratulations on completing this deep dive into feature extraction in NLP. We've covered key techniques like bag of words, TF-IDF, word embeddings, and advanced methods like BERT. Mastering these techniques is essential for transforming raw text into valuable data, directly impacting your model's success. I encourage you to apply these skills in your projects and share your experiences in the comments. Don't forget to subscribe and join our community for more insights into NLP and data science. Let's continue this journey together, unlocking new possibilities in the world of language processing.